I'd like to welcome Doug Rosenoff back, a perennial Haystack visitor.
Thank you, David. I know I'm between you and lunch, and so I'm going to try to keep this short and to the point. Unfortunately, there's a lot to cover, so we'll try to balance that as best we can. So we'll start here. This work was based on intensive work the last 6 months by my team at LexisNexis. And I'm sort of a technical project manager. The rest of these folks are developers. I want to give a shout out to them initially because it's been a really intense few months here. So LexisNexis is a part of RELX. RELX is a publishing house originally that's branched out into technology and technology solutions. It's composed of LexisNexis, which deals with legal publishing, Elsevier, which is scientific and medical publishing, and of course RELX Risk, which is compliance information, and Reed Exhibitions. LexisNexis itself is an international legal publishing and technology company. And the mission is to advance the rule of law around the world. And that's something that we don't take lightly. So not only we are a for-profit company, but we also do a lot of pro bono work in helping countries promulgate their laws and making them accessible to everyone. We've been involved with online publishing since 1973. Kind of shockingly, we were among the very first with that. And we've been using and adopting various kinds of machine learning and AI since 2019. I'm not going to go through a lot of these slides in depth, but this slide is now a couple years old. And so you're looking on the order of 307 million documents and dockets then. Those are artifacts of lawyers and judges for a total of about 3.8 petabytes, and this is about 2 years ago. We grow by Library of Congress size units every few months, so these are out of whack pretty far. But it does show that we've got a tremendous amount of information on the spindle at any one time. So part of that is the problem of search. And I want to really talk about that because generative AI, as you all know, pretty much moved the cheese for search when it came out. And we went from many years of very classical search work, very classical online and offline testing, and working on improving and refining those classic metrics for search. But when generative AI came out, then a lot of that went out the window, and we've been left with trying to figure out how to measure those things in a completely different world. But before we dig too deep into that, I wanted to mention a couple definitions I'll be using in today's presentation. Specifically, at LexisNexis, we use the term ask as the generative AI equivalent to search. We still do both. We have customers that need both. We use the term prompt, either a system prompt, which is an overall prompt that we give to the system for evaluation, and we have metric prompts that we'll be discussing as well. And then the user prompts are roughly equivalent to the query in a traditional search. We use generative AI in a number of products, both internal and customer-facing. We've been doing customer-facing generative AI-generated results now for, it's been several releases back now, not only for search, but also for editorial content summarization, customer document summarization, document drafting, and taxonomy classification and evaluation. All of these are in production today. We're going to be talking about an offline search tool called STF. If you've attended any of my previous talks that I was honored to give at Haystacks in the past, we've talked about STF. It's an internally developed framework for testing generative AI and determinative search, uses SMEs and the classic HRT process to evaluate human opinions on query result pairs, and then generate metrics from those ratings specific to the operation type and the type of results to be generated. STF is based on multiple human raters against a specific rubric. These are not mechanical ratings. These are very much ratings that are done by attorney experts, and so they'll have lots of opinions and they don't always agree. But we value that. We ask them to use their best notion and their best legal knowledge to give us the answers. A key foundation that we hold dear on STF is that HRT work for determinative solutions and SME testing for generative AI solutions have a common process. The meta is the same for both, regardless of what type of evaluation we're doing. And of course, this observation led to some interesting work last year in 2024 and 2025. As I said, generative AI moved the cheese. The determinative model were no longer adaptable to a prompt response model. And that's, seems intuitively obvious, but it took a while for that to process about what that meant for metrics and what that meant for testing. And that process, as we mentioned, remained the same, but the metrics had to change. So let me talk about those. For last year at Haystack, we introduced this notion of first generation AI metrics. And this is for legal content now. So it's not internet general content, but they are useful in that context as well. So we have things like relevance, accuracy, completeness, fluency, authority, hallucinations, usefulness, all those sort of things. And we divide those metrics into primary and secondary types. Primary types are ones that can be taken and assigned relatively straightforward. They're not dependent on another metric. So in other words, they're orthogonal to each other. Secondary metrics probably require that primary metrics have been considered and that you're building on that platform to make the secondary rating. Ratings for the most part are between 1 to 4 on a Likert scale, 1 being poor and 4 being great. Some of the metrics, notably hallucinations, misattributions, and unsupported statements, are binary. If there is no really way to do a 1 to 4 rating on a hallucination presence. So we also require our raters to return user comments and error notes if possible, and we require that all of the metrics be rated, or all of the criteria be completed for each rating before it's turned in. But what that means is that SME relevance ratings for Gen AI require a lot. There's more metrics, so that means there's a lot more time involved for each one. They're longer to rate. Previously, ratings would take on the order of a couple of minutes, maybe up to 10 minutes for long documents. Now they can run to longer than an hour and a half per document, per rater. Complex results to rate. When you get very long legal documents, just consider a Supreme Court case that's been kicked back and forth many, many times, might take hours to rate, lots of reading, lots of citations that have to be chased down inside the documents. So there's a lot more depth of evaluation to get to a rating. Paradoxically, rating need has increased exponentially. When generative AI came out and the cheese moved, that's true for customers as well. And that meant we have to, because of this new paradigm, we have to reestablish a level of trust with the results. And that means to do that, we have lots of testing to confirm that what we're putting out in a product is actually correct and reliable. And just like in the financial case that Gurian mentioned, legal documents and the decisions made off of those can have life-altering consequences. So there's a very high bar here that our customers trust what we have to say. Okay. So last year at Haystack, David and Scott Stoltz and Jeremy Hudson from Moody's and Renee Kriegler all talked about this notion of using LLMs instead of humans to help measure the quality of text generated by an LLM or reg system. That sounded vaguely familiar. That's kind of right out of our elevator pitch. And so I was trained as a geologist and a geophysicist, so when you have a hammer, everything either looks like a rock or a nail. So we immediately thought, well, what do synthetic raters or LLM raters look like? And we had a bunch of these questions that came up immediately out of that. So we looked at things like goals, benefits, and use cases. What do they look like from an architecture and code point of view? What do they need to do aside from ratings? And how accurate is a generalized AI rater compared to a human? And there were a lot of other questions as well. But most of all, and most importantly, how do we get started and when can we go? I'm sorry, I need to move this chair up a little bit. Okay. So we define something called a synthetic rater. And a synthetic rater is a programmatic generative AI construct that mimics SME rating behavior. Simple concept, radical implications, as I'm sure you all are well aware by now from the presentations given earlier this week. We looked at synthetic goals and benefits. Goals are pretty straightforward, and Gurian did a good job of mentioning those. We're talking about significantly reduced time and effort required for relevant studies. We needed to provide a neutral, pluggable, scalable synthetic rater tooling so that we can do multiple generative AIs and services, that is to say not just search, but things like taxonomy, summarization and the like, as well as non-AI services like classical search and citation identification and that sort of thing. We needed a like-for-like testing tool for comparisons. If nothing else, generative AI really increased the requirements for accurate evaluation of by comparison methods. So you've got synthetic to synthetic, synthetic to human, and human to human, all on similar data sets. We needed to leverage as much as possible of our existing code base to do this, and importantly is to provide production and data science level testing tools. Those are two very different audiences. When I'm testing for products, I have a much different set of lenses in place than when I'm experimenting with parameterization. Desired benefits then are tunable and repeatable quantitative testing, comparison, regression, using standardized metrics, a lot more low-cost extension of well-understood and well-used framework, and leveraging of this experience with large business unit generative AI evaluation down to much smaller companies. We have many companies or many local business units that are in smaller countries, and running a full-blown HRT test is a very expensive proposition for them and very many times prohibitively. So being able to do synthetic ratings, at least as an adjunct for human ratings, is a huge time saver for them. I'm not going to go through all of these, but they come down to running the synthetic rater evaluation before or after the human rating, and then doing comparison and regression across those and using those in different ways, either for quality evaluation, for data quality evaluation. One of the interesting things that did come out of this is as much about human nature and psychology as it is about AI. When you show your synthetic ratings to a human rater, can significantly alter their results because they use that as the old lead cow in a wisdom of the crowd situation. So you have to be careful about that, and we're still working on resolving that. And you can use them in different ways. Obviously, you might want to, as Gurian mentioned, keep the extreme results like great or poor that are clear and not have humans work on those. Or you might even get down to the level of saying, for these metrics, we know that humans are great and machines are bad at it, making the ratings. So we might, swap which, in Doug's parlance, left or right-hand side raters that we use. Again, I'm not going to go through these in depth, but a bunch of use cases here: test and tune, LLMs, system and metric prompts, We can do synthetic rater API so that we can share across different groups, both internal and external, once the API is published. And we provide a full set of comparison and regression toolings at the individual rating, at the rater pool, the metric level, and at the job level. So we have multiple scales we can look at, metrics that we can define against those. Wish list, most of these are pretty obvious. The only thing I would point out here is that there is a non-functional set of elements too, notably around scalability and dehydration and rehydration methods, and architectural hosting. One thing that I did want to say and really emphasize, we got ahead of ourselves here. There we go, top button. I'm fortunate to have a grandson who is neurodivergent, and it's really sensitized me to a lot of the elements of working with neurodivergent people. And one of the really interesting things that came out of this is when I really sat back and started to think about what do synthetic raters do, what do they require, and how do we put them together to make them reusable. It was easiest to think of them as just neurodivergent human raters. And that's not meant as an insult either way. It's just an observation that they both have the same tasks, they both have the same set of goals, but they're going through much different paths to get there. So this is what a synthetic rater looks like. This is Bob. He's our generic rater. And those are the pieces that go into Bob. And you'll notice there's 4 primary parts here. There's a set of metadata, there is an attached LLM, there's a set of rater prompts, and these include both a system prompt as well as individual metric prompts. There's a policy block for each synthetic rater. These can be associated back to individual metrics or the overall synthetic rater. These might be things like parameterization. They might be things like examples, various information that we don't want crammed into the prompts can be put into here, even things like stored procedures. And then we have a set of APIs associated with that. I want to take just a second here. If you've been to my talks previously, this slide will be familiar, to talk about the generic sort of SME process. We begin with parameterization over here by some admins, data prompts, the rating rubric, test parameters, and various inputs and filters. Those are used to generate a result set. That result set can be generated on the fly by an API or recovered from scrape files that are then chunked down into pieces. Those result sets are handed into a rating tool. Ratings are collected, stored, and then metrics are calculated. They're analyzed, and then once that's finalized, they're propagated out to test results and rater statistics. When we add synthetic raters to this mix, we wanted to keep things as parallel as possible. Remember that neurodivergent rater thought. So what happens is synthetic raters appear up here at the same level as humans. They get one API to talk to that answer set. They get another API to save those ratings off. Everything else is the same in terms of processing. So that was a real benefit because we didn't have to rewrite all of this tooling. And that meant that we could preserve all of these bits and pieces and all of the hooks that we have for making extensions for different corpora, different metrics, and all of that. It got us to a really nice place. And then when we develop the results, we can look at just the human results. We can look at just the synthetic rater results, but now we can do interesting things like blend those and see what happens and how those results look across the board. Make some really interesting comparisons that way as well. And of course, we generate outputs that can be analyzed in depth later. I want to also talk briefly about comparison and regression. So same way as it worked in the human world, where you appoint a control result in a test result, human raters or synthetic raters can evaluate those the same way, collect and collate the results, generate the control results overall, and build the against the correlation or regression metrics, generate those results in exactly the same way. So by following that process and keeping the notion of synthetic raters parallel to human raters, at every step we leverage the entire environment we had before. Now I want to talk a bit more about comparisons. So Gurian made some really interesting comments about the ones Moody is using. We've had a somewhat different experience because we started at sort of thinking out of it in a different way. Because of our 1 to 4 ratings world, we dove in at a much deeper level and a more granular level on metrics. So we look at things like correlation coefficient, major and minor precision, standard deviation overlap, and inter-rater reliability. We use Randolph's free margin multi-rater kappa because it's algorithmically about the best of the batch as far as we could determine. People can argue what they like for IRR for days, and that's a fun activity. But we chose this one that we've been using for about 6 years. When you do these comparisons, you have a number of choices. As I said, you've got arena style rating, synthetic rater to synthetic rater for the same configuration. There is statistical result variability between the same LLM ranking the same stuff. It's not a deterministic process. How wide that variability is a very important piece of information for us. Synthetic rater to synthetic rater in an arena style competition with different configurations. So maybe you're starting with ChatGPT-3 and you're wanting to just see the difference given the same prompt set for ChatGPT-4. You can do that here with the same set of stuff because it's all the same model. And finally, then you've got human versus synthetic raters for each of these cases as well. One of the interesting things that comes up is wisdom of the crowd. Humans are always correct. And I think one of the interesting takeaways from Gurian's thing is they're not. When you think about his final conclusion where he was saying, well, you know, the synthetic raters were coming up with this response that was true or false, that was directly in opposition to the human results, that was a profound result because the synthetic rater was following the instructions that were given rather than making leaps of intuition by the humans. So I want to talk about results now. Some learnings first though, and I want to preface this. It's still preliminary and these are very early days. Our results are changing daily based on a number of factors and they're improving over time. They're highly dependent on data quality. We didn't expect that to happen quite so much. So things like data set size, human rater experience, and those sort of things are having a profound effect, much higher than we would have expected or even worried about in past studies for more determinative searches. The results are highly dependent on the type and amount of training. We've done 0-shot, single-shot, 2-shot, multi-shot types of training across here and had very significantly different results. We're working with only primary metrics initially. We didn't want to step too far into the deep end. And we've found even in that some metrics, while orthogonal, are much more problematic than others. And the problem of evaluating synthetic rater metrics is an open one. It's very much subject to granularity of the metric. So when you talk about matching human results, it's at what level or how do you abbreviate those rating results into some kind of a mathematical artifact. So we began simply and small by selecting 3 LLMs to test with. And of course, Bob being first out of the gate, 7 megabyte prompt space, Milo, Llama 70 billion, and Claire 405 billion. These results, incidentally, were in the end of March. And so we wanted to look initially at performance. As I told you, whoa. Sorry about that. So initially, humans were looking at a study of 100 different prompts, all of which were graded by 3 humans. So we had 100% compliance on everything. The total rating time was about 175 hours, and the average rating time for each rater for each prompt was 1 hour and 45 minutes. When we turned Milo loose on that, same compliance levels, it took a total of 40 minutes, and each one took less than 30 seconds, giving us a reduction of rating time by 99%. That was convincing for management. This is a good reason to go forward. So I want to highlight this slide. It's a little bit dense to interpret initially, but it really has a lot of information, and it tells the story in a very interesting way. So these are graphs of different metrics, and you'll notice that each graph is divided into the 4 ratings given. So great, good, fair, and poor. And as we look at the vertical axis, that's the number of ratings given by either the human or a synthetic rater at that rating. So for instance, for usefulness, humans are the, I'm sorry, I'm colorblind, I think they're purple diamonds. And you'll notice that they come up from a low level, they peak out in good, decline with fair, and then end with poor. Other LLMs, like Milo here, starts out high and continuously just comes down. Some metrics, like Bob, just go completely off the deep end, and then we've got Milo that's somewhere in the middle. And you'll notice that the behavior on each of these different metrics is very different. And that's kind of a good thing to find out, right? Because if you just average these together, the uncertainty of each metric would be very high. So it's an important thing to consider across the board here now that we can tune for each one of these metrics. So this one is already pretty good. You know, overall, we have good agreement across here, and that's what we want to see. It's not perfect, but it's good. Here, oh my God, you know, obviously lots of work to do here, but look at the metric, fluency. That's not a thing that LLMs do well. So if you ask a LLM that's trained on internet text to go out and write like a lawyer, you may not have great results. And this is reflective of that. Sometimes it's good. Apparently Claire and Milo think that they understand how to talk like a lawyer. Bob and the human, not so much. So, you know, again, it's one of these things that you get a lot of understanding of what's going on in the LLM by looking at these different metrics that are going on underneath. Does that kind of make sense? If it does, just raise your hand, or otherwise we can spend a while longer on this one. Some interesting results for synthetic raters, amazing performance baselines, but these will inevitably degrade. Graham pointed that out too. As we get more metrics, we get secondary metrics and complex ones. As we look at reasoning-based LLMs, and you start asking for augmented information requests and analysis from the LLM for the raters, either the admins or the individual raters. And when you put that comment request or those reasons in front of the numeric rating, then things slow down quite a bit. And dynamic behavior and parameterization changes. For instance, maybe we want to increase the creativity or the temperature in the prompts for a particular metric. That will inevitably reduce this performance as well. But with 99%, we have a great buffer. Necessity for well-curated, high-quality training data. And I'm sure you know, other people will make this observation, but lawyers, scientists, doctors, mathematicians, search professionals seldom agree on things. And the finer the detail gets, the less agreement there is. So this really exposes and emphasizes that synthetic raters are not quite to human skill levels yet. You're not training on the same data. You're not training on the same set of conceptual skills. And they will not replace humans as SMEs anytime soon, if ever, because there are gross gaps in those items. We can ameliorate some of these things with training on legal, building a RAG-based model that's defined with legal content, strictly legal language. That'll improve somewhat. That's something we're in the middle of testing. And there are no perfect IRRs, so there's no perfect comparisons. One of the things that we are watching and starting to examine closely is rating spreads. So when human raters disagree on something, each one of those averages that we compute will have an associated standard deviation. Same deal in the SME space for the synthetic raters, and we can look at the overlap of those comparisons to see whether they're basically saying the same thing, but it's a little different emphasis or not. You need to understand your training data at a deep level. There is no absolutely correct answers for many of these ratings, and so, but we do know it's garbage in, garbage out, and we see that. And then necessity of budgeting in a time of explosive innovation. That's something we're all used to, but that doesn't make it any easier. Challenges, next steps, and conclusions. The same ones that you would expect. I'm just going to touch on the ones in red. One of the things that we probably should have expected but didn't have enough foresight to catch was that synthetic raters have this gigantic impact on UX complexity, and that meant how difficult they are to interpret. There's more metrics, there's deeper results, and we create data queues as well to assist users, but when you've now got a second class of raters that are synthetic, that are being compared to humans, so that's twice as many results, and then you've got up to 6 times as many results to consider if you look at different comparison types and different metrics. It's a pile of data. So, you've got many, many, many pages of what used to be called printout, and now it's web pages to evaluate here. Secondly, we've talked briefly about sufficient curated tuning, high quality data is vital to this effort. Meaningful metrics for measuring ratings quality and how close to human ratings and synthetic raters need to be. So, as I said, meaningful metrics are a granularity problem to some degree. And we can talk about that in depth a little later if you like. More synthetic challenges. How much and when do you show synthetic rating results to human raters? You always want to show them to the people that are interpreting that stuff, but do you ever show them to the human raters? That remains an open question. If you do, where in the process? After they've completed their ratings, when they can't do anything about changing their ratings, or beforehand, help guide them? A lot of interesting non-automatable questions here. How to play to a synthetic rater's strengths is a different matter completely, and one that we haven't really concentrated on because we were just getting him to behave mostly like a human. And how do you compete ROIs? But one of the last things that I find intriguing, I guess more than anything else, is what do you think about blending human and synthetic rater results in the same set? I think Gurian was sort of standing there talking about using that as an average result to, in some ways, and coming pretty good, pretty close to some of their human results. Do you do that across all metrics or metric by metric? Is it really a fair thing to do? Because you're talking about different skill sets going into the mix in training. So, curious, I think that's a good thought experiment to work with. Tactical steps, obviously better and more tuning, different evaluation services. So again, we've got moving to taxonomy, drafting, summarization, similar types of techniques. All of that same tuning will have to happen, but now you're dealing with different corpora and different sets of document structures. Extended determinative evaluations for like HRT for docs or for search engine result pages is also low-hanging fruit here. And then we've got the usual list of difficult problems to work on with contextual chunking, multi-turn generative AI services. When we hand a lawyer back a single response to a question, they're going to want to talk about it. Lawyers are lexically trained, they're lexically adapted to think that way. And so you're going to have long conversations back and forth. And so you have to not only look at how to keep context, when is context interrupted, when do you return to a context, as well as does the continuity between results have meaning. In other words, you aren't wildly veering between different contexts. This third one is particularly ripe for discussion, and I'd love to hear from everybody else here, but when you get a search result back from an AI, it tells you what it knows, but it doesn't tell you what it doesn't know. It doesn't tell you what's missing. In a law case, you can be perfectly right in your argument, but if you don't have the right cites to support it, you may lose. That's happened a lot. All the time we hear about that. So knowing what's missing and what needs to be factored in that's not in the initial response or subsequent responses needs to be figured out. And then we've got, of course, parameter change and stored procedure models to play with. So in conclusion then, the work is not done. Synthetic raters are not yet a substitute for humans. They're still surfacing a lot of use cases. This is a very ripe ground in a lot of areas. As we found at this conference, many people are using them in different ways. System prompt, metric prompt tuning is still very challenging. Document chunking remains a huge problem. What's missing and metricating what's missing is big. And can a generative AI consistently check itself for binary quality metrics? There's been some work done when you've asked an AI to come up with a response, and on Monday, and you ask the same question on Tuesday. Monday it might have had a hard yes. Tuesday it's like, well, maybe. And on Thursday it's like, maybe not. So these kind of things need to be consistent over time. And understanding how we can make a generative AI consistently check itself, grade itself, is a bit of a challenge right now. So I'm happy to take some questions. If you want to come work with us on this problem, let me know. And I want to especially shout out to my team, known as the Jupyter team, as you could tell from all the slides, as well as some lead customers that helped us with this work. So.
Thank you, Doug. Do we have any questions?
Hey Doug, great talk.
Certainly
Enlightening to hear someone else doing a similar problem and approaching it in a slightly different way. My main question is about how you have a set of metrics that you're evaluating, and I was wondering if you have done any kind of analysis on finding like principal components or like the main metrics that you find you can use to yield this is a relevant document to recall, or like how you do that blending of different metrics.
Right. That's a very good question, and we have no magic formula for that. We tend to look at the overall results. We look at, for human raters, we get secondary metrics coming back, so things like authority, things like relevance, and things like that that are more complex tend to guide us, but we don't have an algorithmic equivalent right now for an overall principle guidance. And that makes sense, right? Because people argue about what's true. And so if you had a single result, then you're probably not using that insight that came with that diversity of opinion.
Anu asks, how are you managing or mitigating variability in LLM outputs of your synthetic raters?
Let's see, because I may not be understanding the question correctly, but because we've defined the API that things come in and out of, we force the outputs to be to a format that we're compatible with. So for instance, our results might come out as in a JSON API. Is that what was meant, or is that adequate to his question?
While we're waiting to hear.
Okay.
Hey, Doug.
Hi, Tito.
Hey, how's it going? The chart that you showed, the alignment across the synthetic raters with the human raters,
Right.
I found it fascinating and almost a little troubling that the inconsistencies for some of the judges, meaning meaning the inputs. I presume here the prompt and the inputs and everything's the same. But if you look at these charts across the different dimensions, you see different synthetic raters have outliers. What should we take away from this? Because from first glance, what I would take away is which one do I trust? Especially like, again, the outliers. It isn't as if it was like one LLM that was an outlier. Like if you look at this one, Bob is an outlier in usefulness, and you see actually the human is the outlier in accuracy. It's talk me down from this, because it seems like
I will. And this chart is disturbing, and that's why I put it in. Is it's intended to be disturbing. We as humans want one answer, and we want one way to do things. It's natural. It's an obvious way. What this highlights is that the prompts that work for usefulness don't work for relevance. What this emphasizes is that you have to tune for the LLM. What we did see coming out of here very clearly was the larger the model for Milo and Claire, the more consistent results. They tended to echo each other quite closely, at least in trend, but 70 is a long way from 405. So you'll see differences in there, but overall, shape-wise, the trends are very close. What's outrageous is how far they diverge from humans and from other models. So again, you have to look at what metrics are appropriate to test using this type of approach. Not all of these may be amenable to LLM-based testing. So you may have some metrics that you have humans complete, and they become the standard.
And Milo and Claire were the larger parameter models?
Yes, Claire was 405, Milo was 70, and Bob was 7, and of course the human.
So actually, so they don't actually look too off. It just looks like the larger models are a little bit more optimistic.
Yes. Yep, they are. And optimism is a problem because it shows up both at this end and at this end. You'll notice that humans tend to be divergent a lot of the time on the extremes. So what's happening in the middle here is a different problem.
We're out of time. Since lunch is upon us, let's thank our speaker again.
Thank you very much.